Hi guys, so here we are with class number 9 and we are going to cover transportation in this class. Okay, so when it comes to transportation, it's an important 8 marks question. It can be coming in objective type question also, because there are some objectives, that is the theory part is also covered in this video, and there may be some 2 to 4 marks question for asking initial feasible solution alone. Okay, so when it comes to transportation, we can divide the whole transportation problem given in your book into 3 types. One is finding the initial feasible solution using the Vogels approximation method, and then testing the solution for whether it is optimal or not. Okay, so type 1 problem is the optimality test is success. Okay, and type 2 problem is finding the initial feasible solution and optimality test is failed, and we are finding one more solution. We are reallocating and finding a solution. Okay, and type 3 is degeneracy. Okay, degenerate condition, we are how we are going to allocate. Okay, so there are 3 types of problem, as I said, like this. So in this video I have explained what is northwest corner method, least cost method, and type 1 of Vogels approximation method. Okay, so guys, in case of any doubt, I know there will be a lot of doubts in this video. Okay, so please post your comment and share the link of the video to your friends, and in case you want day-to-day updates on all the video posted, please subscribe to the channel, guys. Let's go on with the class. So guys, so we are here with transportation model. So transportation model is developed by F.L. Hitchcock. This is the first invention. This may be useful for your objective type question, 1941. But in 1947, T.C. Koopmans independently published. So on his own, he also discovered the transportation model for optimum utilization of transportation system. So he created a model for it. So the first invention is F.L. Hitchcock, and the second but it is independently done by T.C. Koopmans. And transportation model, what is it? Is deals with transportation of product manufactured to different plants and factories. And different warehouses. So what is transportation? Transportation is nothing but logistics. So logistics, okay, so how we are going to transport the product manufactured. Okay, so why we are creating a model for it? To analyze the transportation cost. So what is the objective of the transportation model? To minimize the transportation cost. So the objective of the transportation is to find the minimum transportation cost. Okay, so here in the problem given, okay, they would have given a cost matrix, and with the help of cost matrix we need to allocate the demand what the market is giving and the supply what our factories are able to produce. Okay, we are going to allocate the supply and demand. Okay, so what our problem is going to be like, the demand will be given in the question, the supply will be given in the question, and we will be checking if the total of demand is equal to total of supply. Is there any surplus demand, or if there any surplus supplies? Okay, and if there is surplus, what we will be doing, we will be seeing in the problem now. Okay, and the initial feasible solution is the allocation. For example, the cost matrix given in the question is having m number of rows and n number of columns. M plus n minus 1 allocations should be there, which means it is a feasible solution. Okay, so for example, question it has given the 3 rows and 4 columns, which means 3 plus 4 is equal to 7 minus 1 is 6. Minimum 6 allocations should be there so that the solution is feasible. If it is more than 6, there is no issue, but if it is less than 6, it is called degeneracy. So what is degeneracy? It is shown here that allocated cells is less than m plus n minus 1, then it is degenerate. So if it is degenerate, we need to assume some allocations and then we need to proceed with the problem. Okay, so that type of problem we will see in the next class. Okay, and this class we have seen some basic transportation problem. Okay, so Optimum solution is the solution which minimizes the total transportation cost. So we have found the feasible solution, and from the feasible solution we need to find the optimum solution, whether the feasible solution is optimum or not. Okay, so for that there is a few steps to be done that will be explained in this class. Okay, so balanced unbalanced problem. Okay, what is balanced is total demand for our products is equal to total supply or total amount produced. Okay, but in reality there will always be some differences. Okay, so in case if we have less demand than supply is more, we will create dummy demand column, and similarly we will create dummy supply columns if supply is less than demand. Okay, so we will see that in problem. No, don't be confused. So balanced unbalanced problem means, balanced means the total demand given in the question is equal to total supply given in the question. Unbalanced means these both are not equal, either demand is higher than supply or supply is higher than demand. So that is the definition. Okay, so for solving transportation problem we came out with a method called northwest corner rule, and then we did some improvements to find lowest cost method, and the third method is the Vogels approximation method, and that is the best among these methods. Okay, so northwest corner method, your book has not given any example problem on that, but there may be a situation where you may get some 4 or 5 marks question to solve a northwest corner rule. So it's better that we can see a simple example for that. So what is northwest corner rule? Okay, select the northwest corner cell of the transportation table and allocate as many units as equal to the supply or demand. Okay, so the first allocation in this problem will be done in the northwest cell. So what is northwest cell? For example, there are 4 cells like this. What is northwest? And this is called northwest cell. So this is called northwest cell. Okay, so in this case, after allocation we need to adjust the supply and demand, and if supply or demand is exhausted, we will exhaust the supply and demand available for each rows, and this procedure will be continued until all the allocations are done. Okay, so guys, I'm moving into this problem. There is a company and they have a production capacity, which means this is supply 50 plus 75 plus 25, which is 150. Okay, each day minimum each day the firm must furnish its 4 retail shops. So this is the demand. 20 plus 20 plus 50 plus 60 is also 150. So guys, in this problem the demand given in the question is equal to the supply given in the question. So this is a balanced problem. Okay, so the supplies are given here in the question and demand is given here in the question. Okay, and the transportation cost is given below. So all this matrix is called transportation cost. So guys, this is called transportation cost. Okay, so economic by northwest corner method I am going to work out this. So I am just taking what is given in the question. This is the company. Here I have taken the supply figures, here I have taken the demand figures. Okay, and these are the these are your P1, P2, P3 or your production capacity. Okay, and these are your retail shops, R1, R2, R3 or your retail shops. Okay, so guys, now how I am going to proceed. Okay, northwest, the most northwest cell is this cell. This is the northwest cell. Okay, so here I have a demand of 20 for this column. I have a demand of 20 for this column, and I have a supply of 50 for this column. I have a supply of 50. So which means I can allocate maximum 20 because 20 is the demand. I can allocate 20 here. This is the northwest cell. So once allocated, since this column is exhausted, I am cancelling this column. Next, if you see, out of this 50, we have already allocated 20. So the balance is only 30. Okay. So guys, now I am coming to the northwest cell once again. Here the out of the remaining cells, the northwest cell is, this is the northwest cell. So here I have a demand of 20 and I have a supply, remaining supply is 30. So maximum I can allocate 20. So I have allocated 20 to this northwest cell. So since the demand is exhausted, I am cancelling this column. So already 20 is allocated, so you can cancel this. So remaining you have only supply of 10 in this production unit. So out of the remaining, the northwest cell is, this is the northwest cell. So you have 50 as the demand, you have only 10 as the supply. So I am allocating all the 10 to this cell. So since this row is exhausted, I am cancelling this row. So out of the remaining cells, this is the northwest cell. So here 10 we have already allocated. So the demand 10 is already solved. The balance demand is 40. 40 is the balance demand. So 75 I have the supply. So out of 75, 40 I can allocate here. So 40 I have allocated, which means this column demand is completely over. And out of 75, 40 is already allocated, which means I have a supply of pending 35. So out of the remaining two cells, the northwest cell is this cell. Okay, so balance is 35 and hence I will allocate 35 here. Okay, and the remaining, so this row is exhausted, so I am cancelling this row and I am finally left out with only one cell. I don't have any option, so 25 I am allocating to this, and while I allocate 25, 35 plus 25, 60, and even this demand is solved, and this is how the allocation is done. So what is the cost of transportation? Cost of transportation is 20 allocated to the cell of 3 cost. So 20 multiplied by 3, 20 multiplied by 5, 10 multiplied by 7, 40 multiplied by 8, 35 multiplied by 2, and 25 is allocated to this cell 2. So 25 multiplied by 2. So if you add all this, you will get the cost of transportation. So this is about northwest corner rule method. So guys, any doubt, please share a comment. Least cost method. So in this the approach is slightly different. Here in the previous method we allocated to the northwest cell, but here we are going to allocate to the least cost cell. Okay, the same problem is taken for as an example. Same problem is taken here. So I have the factory here, which are the production units. I have the retail shops given this side. I have the supplies taken here, and I have the demand taken here. Okay, so here out of the total, this is the given cost matrix, and the same cost matrix is taken. Okay, so out of the total cost matrix, what is the minimum cost we need to find? But here minimum cost we have 2 is the minimum cost, but that is repeated. So 2 is here, and we have 2 here, and we have 2 here also. So I need to allocate accordingly. So here there is a 2, which means this is a least cost cell, and here there is a least cost cell, and here also there is a least cost cell. Out of the total number of cells, only 2 is minimum. So I am going to allocate as much as possible to these cells. So out of 75, 20 is the demand here. So I will allocate 20 to this cell. So which means out of 75, 20 is allocated. Remaining I am left out with only 55. and since this column demand is exhausted, I am going to cancel this column. Next, I am left out with these two, and here there is a 2. I have 55 in my supply and the demand is higher. So all the 55 I can allocate here. So I have allocated 55. So this 60 demand, 55 is already closed. So I am left out with 5 demand. Okay, here I have a 2. Here I have a least cost cell once again. So out of 25, this column requires only 5 demand is unsatisfied. So I'm going to allocate 5 here. So this will become 20 as the remaining supply. So this column demand is closed. So I'm going to cancel this column. So I'm going to check what is the least cost available after this. So these are the remaining cells. Out of the remaining cells, 5 is the least cost. Okay, so here there is a 5 and here also there is a 5. Okay, now this column, the supply is already exhausted. So I'm going to cancel this row. Okay, so this is of 5 and I here have 50 as my supply and I can allocate 20 because 20 is the demand here. So I will cancel this 20. I am going to allocate to cell least cost cell with cost of 5 and the remaining would be 30 will be my remaining supply. So 20 I have allocated here and this column demand is met and I am cancelling this. Out of the remaining 2 cells, 7 is the least cost. I have supply of 30 here. Here the demand is 50. So I can meet 30 and my pending demand would be 20 and 30 is allocated to this cell and this row is exhausted. So there is no other option. I have only one cell where it is 9 and I have 20 and I have 20 and there is no issue. I'm going to allocate this 20 to solve this demand. So 20 is allocated here. Okay, which means the problem is completely solved. Similarly, the cost of transportation will be what is the allocations to the cell multiplied by the what is the cost of the respective cell. That is the cost of transportation as it is calculated here. Okay, so we will move to the next method. So the next method is Vogels approximation method. So guys, all the problem given in your book is based on Vogels approximation method. This is very simple problem. Okay, so we will see some steps. If I say the steps, you will be confused, but it's better to know the steps. And this is the right point for that. Okay, so what does this method do? So this method is preferred over other 2 methods. So this may be asked in your objective type question. Okay, in this method we will be calculating penalty for each row and column. Okay, and how the penalty will be calculated? Penalty is nothing but the smallest cost. The difference between the smallest cost and the next smallest cost is the penalty. So now for rows and column we will calculate penalty and we will identify the largest penalty. Okay, and for the largest penalty we will do the allocations first. Okay, out of the largest penalty, whether the penalty is relating to a row or a column, we will give the allocations to the smallest cost cell of the respective row or column. So this may look bit confused guys, but in the problem you will be clarified. Okay, so in case there is a tie in the penalty, you can select you can arbitrarily select a cell, but if you have more number of assignments possible, okay, so to reduce the computational work, if there is a tie in the minimum cost also. Okay, so there is a tie between 2 penalties. So penalties are calculated for a row and column. So if there is a tie in the penalty, select the row or a column which has least cost. Okay, which has the least cost. If there is a tie in the least cost also, okay, select the row which will have the maximum possible assignments. Okay, so you can try to do assignments, and which can get maximum assignment, you can select that. Okay, don't be confused guys, we will go with the problem now. Okay, so remaining thing we can explain in the problem. So here this is a question which is given in the your book guys. So a cost conscious company now for the next month 300, 260 and 180 tons of stone requires. So which means this is the demand. So demand I am taking in my rows. Okay, I am taking demand in my rows. So 300, 260 and 180. So 300, 260 and 180 I am taking the demand here. Okay, so out of the three mineral fields, the fields are M1, M2, M3 and they yield this much. So this is the supply. So they have supply, I am taking the supply as a column and supply is mentioned here. Okay guys, now the transportation cost matrix is given here. Transportation cost matrix is given here. So we need to find the optimal transportation plan and the transportation cost. Okay, and what is the quantities to be sold from M1, M2, M3 respectively. So guys, we are checking the total of demand which is given in the question is coming to 740. Total of supply is coming to 850. So guys, here the demand, total demand is not equal to total supply, which means this is a unbalanced transportation problem. Okay, but you can see that supply is higher than demand. So demand we have taken as column. So columns are the demand. Okay, so in the question we have given three columns. We have been given three columns. So since demand is lesser than supply, I am including a dummy column. Okay, and the dummy column will have zero cost. The dummy column will have zero cost. This is the dummy column and this will have the zero cost. And what is the difference between supply and the demand? 850 minus 740 is 110. So 110 is the supply of this dummy column. Now my demand is equal to supply. So guys, in the Vogels approximation method, the first step is to make the problem balanced by adding a dummy row or dummy column. In this case, supply is greater, so we include a dummy column. There may be a problem in which demand is greater, there you may include dummy row. Okay, so guys, next we are going to start calculating the penalty. So I am going to calculate what is called as P1. So penalty should be calculated for column as well as for row. So okay, so P1. So I am going to calculate P1. P1 is nothing but the penalty. Okay, penalty, how it is calculated? The difference between the smallest cost and the next smallest cost. Okay, now I am going to calculate for the rows. The smallest cost of this row is 0 and the next smallest cost is 6. So 6 minus 0, it is 6. So similarly 0 is the smallest cost. Next smallest is 4. 0 minus 4, it is 4. And similarly you can calculate for this. Similarly for columns, what is the least cost here? 5 is the least cost and next least cost is 7. So 7 minus 5, it is 2. And similarly you can calculate for the columns also. So compare all the penalties 2, 1, 1, 0. And in the rows it is 6, 4, 5. The highest penalty is 6. The highest P1 penalty is 6. So we need to start allocation from there. Okay, so here I have for this column I have 250 as the demand. Okay, so out of the 250 demand, I am going to allocate least cost is 0 in this row. The least cost is 0. I am going to allocate as much as possible. So out of 250, I am going to allocate 110 is the demand here. So I am cancelling 110 demand. My demand is becoming 0 here. So this column is exhausted. That's why this column is cancelled. This column is exhausted. And my 250 is cancelled and 110 I have allocated here. 110 I have allocated here. So balance is 140. Balance is 140. So guys, now I am going to calculate next penalty, which is P2. So P2 is the penalty here. Next penalty I am calculating. So this column has gone with the remaining number of columns. So we have only now 3 columns and we have only 3 rows. So for this we need to calculate what is the minimum cost. 6 is the minimum cost. The next smallest is 7. So 6 minus 7 is 1. Here 4 is the minimum. 5 is the next minimum. 5 minus 4 is 1. And here 5 is the minimum, and once again you have 5 is the next minimum. So the penalty is 5 minus 5, 0. Similarly for the column, least cost is 5 and 7 minus 5 is 2. So similarly you are finding for the columns. Okay, so since this column is exhausted, we need not find a penalty for this column. We need not find penalty here. Okay, so compare the penalty highest 1 0 1 1 0 2 1 1. So 2 is the highest penalty. So we have a demand of 300 here. What is the least cost? Sell 5. What is the supply available? 320 I have supply, so I can allocate fully. So I am exhausting this 300 and 300 I am allocating here, and this 300 is completely 320. 300 is allocated, so balance you have 20 for allocation. So since this column is exhausted, I am striking off this column. So guys, 2 columns are exhausted. Okay, we have only 2 more columns. So now I am going to calculate P3. So every time when you exhaust a particular row or a column, calculate the next penalty. So here I am calculating P3. So here 2 columns are exhausted, only 2 more columns are there. Here you need not find the penalty. So what is the least cost? 4 is the least cost. Next least cost is 5. So 4 minus 5, 1. And similarly here 5 and 6. 6 minus 5, it is 1. And for rows you have okay. So here you have 6 and you have 7 and you have 1 is the left out. Okay, so 1 is left out, and okay, so 7 minus 6 is 1, and here you have 3 rows once again, which is 4 and 9, because these 2 are cancelled. We have only 4 and 9, so 9 minus 4 is 5, and 5 and 5 0. So 0 is the penalty. So what is the highest penalty, guys? So 5 is the highest penalty. I have only 20 of my demand supply remaining. So 20 I am cancelling, and I have 20 I am cancelling. So which means I have exhausted this row. And 20, what is the least cost? 4 is the least cost. I am allocating 20 here. So out of 260 is the demand available. So 260, 20 is solved. So I have 240 more as my demand. So I am exhausting this row, guys. Okay, so this row is exhausted, so I will cancel this row. So guys, 2 columns and 1 row is exhausted. So now I am going to calculate P4. So I am calculating P4.
So in the P4, once again the same rule. Okay, so in case any doubt in the penalty, please share a comment in this video. The highest penalty for P4 is 2. So for 2 I have 240 as the demand. And what is the minimum cost? So 7 is the least cost and 5 is the least cost. So to this cell I need to allocate. How much I can allocate? 280 I have as my supply. So I can allocate all the 240 and I can exhaust this 240. So full 240 is allocated here. So out of the 280, 40 supply is remaining. So since I have exhausted this column, I am going to cancel off this column. So guys, 3 columns and 1 row is exhausted. Okay, so now you have very limited options, okay, which means this column is exhausted. So you have only this as a unallocated cell, okay, and this is an unallocated cell. Okay, so these two are unallocated cell. So here you have the least cost as 5. So how much you can allocate? So 180 is the demand available here. So out of 180 you can allocate 40 here. That's what we have done here. 40 we have allocated here, because out of the remaining cell, 6 is the cost here, 5 is the cost here, and 5 is the least cost. I have allocated 40 here, which means 40 is my supply that is exhausted. Since 40 supply is exhausted, I am going to cancel off this row, and remaining I have 140 as my demand here, and here I have 140 my supply pending, and that 140 can be allocated here. This is the only available cell, so I am going to allocate this, and this column is also exhausted. So guys, which means we have exhausted all the rows and all the columns, okay, and which means we have allocated all the supply to all the demand. Since we balanced the problem, matched the demand and supply at the beginning of the problem, everything is allocated. Okay, so now we have found a solution. So how much allocations are there, guys, in the problem? In the answer, here there is allocation 140, 300, 2, 3, 4, 5. So we have 5, and here you have 110 allocation. Okay, so we have 6 allocations. So there are 3 rows and there are 4 columns, which means m plus n minus 1, which is 3 plus 4, number of rows plus number of columns minus 1 is equal to 3 plus 4 minus 1 is equal to 6. Okay, number of allocations in the answer is 6. So since the number of allocations is equal to or greater than the m plus n minus 1, the solution what we have obtained here is a feasible solution. Okay, but it is not, we don't know if it is optimal or not. So for that we need to do a test for optimality. So for the same problem we are going to test the optimality of the solution. Okay, so guys, remember the answer as of now. What we have did is we have found the cost matrix is given in the question, supply and demand is given in the question. We have taken the total of supply, total of the demand, and looking for whether it is matching. No, this is not a balanced problem, so we are trying to match the demand and supply. Since here we have demand lesser than supply, we are including a dummy column. Okay, whatever is this total demand minus total supply, that gap is 110, and 110 will be the dummy demand. Okay, and then we started calculating the penalty, and what is the highest penalty? We are starting allocation, and after allocation we are exhausting the row or column whichever is exhausted. Similarly, we are calculating next penalty and further penalties. Okay, and for every penalties we will find the highest penalty, and for the highest penalty, if it is row, you will allocate the demand to the supply, and the highest penalty is in column, you will allocate the supply to the demand. Okay, on the either way you will exhaust the rows and column, cancel the rows and columns, and finally exhaust all the demand and supply available. So now we are checking how much allocations we have done. In this problem we have done 6 allocations. So number of rows plus number of columns minus 1 is nothing but m plus n minus 1 is, in this problem it is 3 plus 4 minus 1 is 7. 3 plus 4 minus 1, it is 6. So we have done 6 allocations. So our solution is feasible, but we don't know if it is optimal. So we are going to check if it is optimal. So the same question I have taken here, guys. This is the answer which we discovered in the last slide. So this is the supply side, this is the demand side, this is the allocations. All the circles what we have done is the allocations what we have done. Okay, this is the dummy demand column. This is the answer. So here we have 1, 2, 3, 4, 5, 6 allocations. Okay, so we have 6 circles, right? So we have 6 allocations. So we have m plus n minus 1, which is 6 allocations. So it is a feasible solution. Now we are going to check if it is optimal. So all circled values above in the above figure, okay, or the cells which are allocated cells. All these are allocated cells. So this is called initial feasible solution. The solution may or may not be optimal. So now we are going to test for optimality. So test for optimality is done by MODI method. So what is MODI? Is modified distribution method. So which means this method will detect whether the solution is optimal or not. If it is optimal, yes, our feasible solution is optimal solution. If it is not optimal, then our feasible solution is not optimal. So we need to do some reallocations to find the optimal solution. Okay. So if optimality says, so this is what is described here. So now we are going to find ui and vj. Okay, so ui is taken in the column side and vj is taken in the row side. Okay, so I am going to assume as my first u as 0. Okay, you can assume the first u value as 0, or you can assume whatever is having more number of allocations. For example, if my third row is having more allocations, I will assume this row as 0. But in this case, all the row is having two allocations. Okay, each row is having 2 allocations. So I am assuming my first row as 0. So here I have assumed 0. Now I need to calculate Vj. So how to calculate Vj? Ui plus Vj is equal to Cij. Cij is nothing but the cost of the cell. Okay, so here only for allocated cells we need to calculate. So which means here you have a allocated cell. Cost of the cell is 6. So what is V? V I don't know. V plus U. So 0 plus Vj is equal to 6. Okay, so Vj is equal to 6. So I have calculated 6 here because Ui plus Vj is equal to Cij. So Cij of this cell is 6. So 6 is equal to Ui is 0. Vj we don't know. So Vj plus 0 is equal to 6. Vj is equal to 6 minus 0 is equal to 0. So guys, here you have 0, which means Cij is equal to 0. Ui is 0. So Ui 0 plus Vj is equal to 0. So Vj is equal to 0. So we have found this. Okay, so we have found one UI value and two VJ values, and here there is a allocated cells. Okay, so here using this 0 we cannot find any other value because there is no other allocated cells here, but using this value we have a allocated cell here, so we can calculate. So here Cij is 5, UI I don't know. Okay, VJ is 6, so 6 plus UI is equal to 5. UI is equal to 5 minus 6 is nothing but minus 1. So minus 1 is calculated here. Okay, so using this, once again I am going to see whether I can find some other value. Okay, so for this column we have calculated. Here there is a allocated cell, so I can find a VJ here. So cost is given here. Cij is 5. Okay, UI, yes I know it is minus 1. So minus 1 plus VJ is equal to 5. VJ is equal to 5 plus 1 is 6. So it is 6. Okay, so guys remember UI plus VJ is equal to Cij, and I am going to use that on allocated cells only to find the UI and VJ values. Okay, so what I am left out now here. Okay, now I found for this column, here there is a allocated cells and I have not yet found this U value. So I am going to take this value. Cij is the cost of the cell. Okay, Cij is 4 here. So for this example, Cij is 4 here. 4 is equal to, I know the Vi value which is 6. So 6, I don't know the U value, plus UI. Okay, UI. So UI is equal to 4 minus 6 is equal to minus 2. So for this row, okay, minus 2 is the UI I have calculated here. Okay, so once again there is a allocated cell here. So what is Cij? Cij is 5. So Cij is equal to UI plus Vj. So 5 is equal to UI. Do I know the row value? Yes, I know it is minus 2. So minus 2 plus Vj plus Vj. So Vj is equal to 5 plus 2 is equal to 7. Yes, I found the Vj value here. Okay, so guys, be very careful in this. Okay, so if you have a doubt, please share a comment. So we are checking the optimality of the solution. We found the UI and we found the Vj. Okay, so guys, now we are going to find Dij is equal to Cij minus Ui plus Vj. Okay, so here we are going to find the Dij values, and Dij values will be found for only unallocated cells. Okay, only unallocated cells. So here Cij is 8 minus 0 minus Ui plus Vj. Ui plus Vj is 0 plus 7 is 7. 8 minus 7 is 1. This is the Dij values. Okay, Dij values is given in blue color. Okay, so for this, here there is an unallocated cell. So Cij is 7. Okay, Vj is 6 and Ui is 0. 6 plus 0 is 6. 7 is Cij. So 7 minus 6 is 1 is the Dij value. Similarly, for the unallocated cells, you are finding the Dij value. If Dij value of all unallocated cell is greater than 0, the solution is optimal. So here you can find the Dij value as 1, 1, 5, 2 and 1. All the Dij values are greater than 0, hence the given solution is optimal. So guys, this is the basic type of problem of Vogels approximations method. First, balance the problem. Next, including some dummy rows or dummy columns. First, balance out, calculate the penalty, find the maximum penalty, For the maximum penalty, if it is row or column, allocate the row value or row value or column value to the least cost cell of that respective row or column. Then try to exhaust the row or column, and then keep on finding the further penalties till you exhaust all the row and column. Once exhausted, just count how much number of allocated cells are there. If allocated number of cells is greater than or equal to m plus n minus 1, then the solution is feasible. What is m plus n minus 1? It is nothing but number of rows plus number of columns minus 1. So find the feasible solution, then check for optimality. For checking the optimality, you need to find the ui values and vj values using the allocated cells. Okay, then after finding ui and vj, find the dij values for the unallocated cells. Dij value is nothing but cij minus of ui plus vj. Okay, so find the dij values. If all the dij values is greater than or equal to 0, then the solution is optimal. So it is not greater than 0, it is greater than or equal to 0, the solution is optimal. If it is lesser than 0, solution is not optimal. Okay, for non-optimal, we need to do reallocations. That we will see in the next class, guys.
So guys, that's it with class number 9. So meet you with class number 10 shortly. So in class number 10, I will be covering the type 2 and type 3 problems. So in this video, I have covered the transportation problem using Vogels approximation method, which is type 1, which means I have found the initial feasible solution and I have tested the optimality test of the solution, and the test is success. The next type will be covered in the next video. There are two more types. One is the initial feasible solution and optimality test is failed. So I need to reallocate to find the feasible solution. The type 3 is degenerate condition, which means number of allocations is less than m plus n minus 1. So how we are going to approach that problem? So these two types of problem will be seen in the next video. Thank you guys, and please subscribe to the channel for getting the frequent updates on the video posted, and as well as any doubts, please share a comment, and if you have a lot of doubts in your initial feasible solution, I can also explain it more clearly in the part 2 video of transportation. Thank you guys.